Hello ladies, in this video we're going to go through solving quadratic equations. I'm going to cover both 5F and 5H, okay, so I'm going to skip 5G, which is applications, just because 5F and 5H are quite similar. Now, with the second part of chapter 5, so we've already looked at the factorizing. The second part is just an extension of factorizing. So if you're okay with factorizing, you'll be okay with solving, because we're just taking it one step further and we're letting those equations equal to 0. Now, if you're wondering why we let them equal to 0, it's because we're basically looking for where the graph, so a quadratic can be graphed, and I'll show you in a sec what it looks like. It's where it crosses the x-axis. So if we let it equal to 0, we're effectively letting y equal 0 in your equation. And remember, when we do linear equations, if we want to find the x-intercept, we let y equal 0. It's the same for quadratics. And the graph of a quadratic is called a parabola. So if you hear me saying parabola, it's just the graph of a quadratic equation. Okay, so I've got my calculator here, and I might need to, oh no, you might be able to see it quite okay. I'll just show you now what a parabola looks like. Okay, so I'm going to add graphs. Now, in your graphing screen, this f1x, that just means f is just your function. So it's just saying the first function where x is your variable. Now, same as saying y equals. So I'm going to put in just your basic parabola, which is x squared, and there it is. Okay, so there's a parabola. Okay, it makes a U shape, and we have all different types of parabolas. So the parabolas can become wider, they can become narrower, they can move up or down or left or right. It's the same as a linear equation. Okay, we have an infinite number of linear equations. It's the same with the parabola. And it can also be a negative parabola, so it goes upside down. But we don't have to worry too much about that until we get into parabolas. But I'm just showing you here why we let it equal to 0. So we can see here this quadratic is touching the x-axis there at 0. But let's just do another one. So I'm going to go back to my screen, and I'm going to put a factorized equation in. So let's do x minus 2, x plus 2. Okay, so there it is, and you can see it's crossed the x-axis. Okay, this one was on the the blue one was on the x-axis. The red one is over the x-axis, so that means we have a solution. So if you look at your factorized form, x minus 2, x plus 2, if we were to solve that for 0 using what we call the null factor law, that basically tells you your x-intercepts. So we're here at x equals negative 2 and x equals 2. So as we go through this video, it'll probably make more sense when we get our solutions what they relate to. So they just relate to where your graph crosses the x-axis. All right, I'm going to show you another parabola. So this time I'm going to show you one that doesn't cross the x-axis. So let me do 3. Okay, so this black one here doesn't cross your x-axis. So I'll just move this so you can see the label of it. This parabola, if I look at this equation, it's been shifted up by 3. You don't have to know that just yet, but when we do parabolas, you'll explore all the different sorts of transformations. But this sort of parabola, if you look at it, we can't factorize it any further. And well, we can't factorize it. It just stays as x squared plus 3, but we can't let it equal 0. Okay, when you think if we let that equal 0, we're going to have x squared equals negative 3, and then we're going to be taking the square root of a negative number, and we can't get a real solution to do that. So basically, if you can't solve it, it just means it doesn't have any x-intercepts. And another example, which I might just quickly do, is if the graph was flipped. Okay, so basically my graph is going to be an upside down parabola now, and we're just going to move it down so I can show you. Okay, so this purple one, another type of parabola, is been reflected, okay, along the x-axis, so that just means it's flipped over, and it's moved down too. Okay, and again, it doesn't cross the x-axis, so it has no solutions, no real solutions. All right, so I'm just explaining that when we go through, if you're wondering, well, what is the point of this? It all relates to the graph of the quadratic, which is called a parabola. Okay, so let's move on to just solving. All right, so the null factor law, basically it's a fancy name just for saying, well, if two or more numbers are equal to 0 when you multiply them, then one of them or all of them have to be equal to 0. So even though it's written there, I'm going to just show you on the side here. So if we had two numbers, let's call them A and B, and that was equal to 0, it means that one of those numbers have to be equal to 0. So if A was 0, okay, your whole equation is true. Or if B was 0, your equation is still true, okay, because when you multiply any number by 0, you get 0. You can have both of them equal to 0. Okay, so that's basically what it means. So when we're factorizing, and I'll use the example I had in that graph before. So we've got x plus 2 times x minus 2 equals 0. So that means either x plus 2 is equal to 0 or x minus 2 is equal to 0. So even though when we're solving quadratics, we're not looking at singular numbers, we're looking at the factorized form, and they're usually terms within a bracket. And that means x is equal to negative 2 from this first equation, and x is equal to 2. And as you can remember, let me just get it back on my graph actually. This red one, it did cross the x-axis at 2 and negative 2. All right, so I'm going to do some questions now. I just thought I would explain that for you. I'll just pause and rub that out. All right, so looking at question 3 from 5F. So we're going to start off with some basic ones. They will get more complicated, and when we do 5H, we're going to be looking at completing the square again. But as I said before, if you can factorize, then you're fine. Okay, so let's solve this one. So 3A. So this is just a basic quadratic. Don't worry about this equals 0 just yet. We're just going to focus on this left-hand side. So we need two numbers when multiplied give us 2, and when added give us 3. So that's going to be 2 and 1, x plus 2 and x plus 1. Okay, so two numbers when multiplied give us 2, so that's 2 and 1, and when added give us 3, so 2 plus 1 is 3. And let's let that equal 0. Now remember our null factor law, so this is kind of like your A, and this is your B. So that means either A is equal to 0, so x plus 2 is equal to 0, or x plus 1 is equal to 0. And see how I've separated them? That's how you would do your working out. So we're solving now for x. So I'm just going to take away 2 from both sides. So x is equal to negative 2. And here we're going to have x is equal to negative 1, just because I took negative 1 from both sides. Now, and that's it. So basically, this is your x-intercepts, okay? And I might just show you this one. I won't do the graph of every single one, just to show you. So I'm just going to pause for a sec. All right, so I'm going to enter this equation in. Now, when you put it into your calculator, this 0 is basically what y is. So as I said before, the f1 of x is what y is. So all we need to do is plug in our equation. So we had x squared plus 3x plus 2. Okay, we don't put the equal 0 in because we're basically, that's what we're letting y equals. This is just your general equation. And there it is. So remember, I said the solutions were negative 2 and negative 1. And you can see there, if you are having trouble seeing what that is, you can actually, there's a way to do it. I might not do it now because this video will take forever if I show you. But for this basic one, we can just read it off the scale. Okay, so you can see it's there at -1 and -3. You don't have to graph them every time. I'm just showing you how these equations relate to the graph. All right, since we don't have enough space, I'm going to skip to 3C. So this time, two numbers when multiplied give you 8, and when added give you -6. So that's going to be -4 and -2. So we just separate the brackets now. So x minus 4 is equal to 0, x minus 2 is equal to 0. So that means x is equal to 4 and x is equal to 2. So remember, they're the x-intercepts of your parabola. All right, moving on. So let me just do a page break so we've got a bit of space. All right, solve the following quadratic equations. So here we've got non-monic quadratics. First, before you start, you should always think, well, can I take out a common factor? In solving quadratics, the common factor, if you take it out, it makes it so much easier for you because it doesn't really play any relevance with your quadratic. That factor just actually either widens or narrows your quadratic. But for these ones, we're going to have to solve them. They're non-monic quadratics. So remember, we need to multiply the two numbers, a and c. So we're going to have 2 times 12. And if you can't remember how to solve non-monic quadratics, 24, you'll need to go back and, practice them a little bit more. We are going to do the quadratic formula, which is going to make things a lot easier, but make sure you can still factorize them this way. Okay, so we've got two numbers when multiplied give us 24, and now we need to find, multiply a and c, so 2 times 12 is 24. So we're looking for two numbers when multiplied give us 24, and when added give us the coefficient of x, which is 11. And that's a nice, easy one, 8 and 3. I think when I was doing this chapter for the video, it took me, I had to pause it and think about what those numbers were. But as I said before, you just use the quadratic formula. So if these are a bit of a pain in the butt, eventually you'll use the quadratic formula, unless you don't mind doing it this way. Okay, so that means now we've got 2x squared, and instead of the 11x, I'm going to have 8x plus 3x, and then we've got the plus 12 on the end, and then we factorize by grouping. So I'm going to put that equals 0 because we are solving. All right, so we take out the common factor for the first two terms, so it's 2x, then we're going to have x plus 8. No, we're not, we're going to have x plus 4. Sorry about that. And then we got common factor here is 3x plus 4. Remember, you want the same factor there. So if you didn't get that, you've probably made a mistake somewhere. And then we're left with x plus 4 times 2x plus 3 is equal to 0. Again, the order doesn't matter if you did it around the other way. That is fine, okay, because when you multiply two numbers together, it doesn't matter the order. All right, now we can use the null factor law. So x plus 4 is equal to 0, or 2x plus 3 is equal to 0, and then I just solve for x. So this first one, x is equal to -4. This one here, we're going to have 2x equals -3, and then divide both sides by 2. So you get x equals -3 on 2. You could write that as -1.5, but as we head into more complicated mathematics, it's so much easier just to leave it as a fraction. All right, I'm not going to do the other two because you've done non-monic quadratics before. So let's move on. It's going to be a long video if I don't keep skipping questions. Okay, let's do a page break. All right, so this one here I put in because if we're factorizing, it's easier if we put it in this form, expanded form. So let's just rearrange 6a. So I'm just expanding this bracket first. So we'll have 2x plus 24. And then I'm going to bring everything over to the left-hand side. Okay, and then I can solve. So set up my brackets, equals 0. I know the first is going to be x. Okay, so then we need two numbers when multiplied give you negative 24 and when added give you negative 2. Now, because this is a negative, I know one of my numbers is going to be a positive, but the other one has to be a negative. All right, so 6 and 4, okay, and because there's a negative 2, the bigger number is going to be the negative 6. And if you're ever unsure, you can just expand your bracket. So x times x gives you x squared, x and negative 6 is negative 6x plus 4x gives you negative 2x, and then 4 times negative 6 gives you negative 24. All right, let's separate now. So we've got x plus 4 equals 0 or x minus 6 equals 0. So that means x is equal to negative 4 or x is equal to 6. Okay, so just factorizing it. And then, yeah, solving for 0. Okay, let's move on to the next one. So I should have done all my page breaks before I started the video. All right, solve the following by first writing in the expanded form. Okay, so let's have a look. I'm going to rewrite it first, actually. Now, don't make the mistake and cancel this x with this x, which you can't do because you've got two terms here, okay? And you can't cancel out because of this 84. But remember, we want to get it in this form. So I'm looking at this and I can already say, well, if I multiply both sides by x, this is going to give me the x squared. So that cancels out there. So we've got 5x plus 84 equals x squared. And then I'll just bring everything over to the same side. Try to keep your x squared as the positive. Okay, so if I brought the 5x over, it becomes a negative. And then the 84 becomes a negative. And then let's let that equal to 0. All right, I hate big numbers, but because you're putting me on the spot. So we need two numbers when multiplied give us 84. Or negative 84, sorry, and when added give us negative 5. Now again, similar to before, because this is a negative, one of your numbers is going to be a negative and one is going to be a positive. All right, so thinking hard, I might have to pause the video. Okay, so 12 and 7 are my numbers. Because this is a negative 5, it means the bigger number is going to be the negative. And there we go. And if you're ever unsure, just do your expanding. Now, some of you will eventually just look at these and know that x is equal to negative 7 and x is equal to 12. But if not, just keep doing your working out like this. So x is equal to negative 7, x is equal to 12. All right, moving along. Now, 5h is completing the square. And when we did this, first of all, some of you were saying, what is the point of completing the square? Completing the square will get your parabola into what we call turning point form. So what I might do is complete the square with 4a, and then I'll explain what I mean by turning point form. Okay, so we've got x squared plus 5x plus 2 is equal to 0. So let's scroll. Okay, so when we're completing the square, we identify b. So in this case, b is equal to 5. Okay, b just being your coefficient of x. And we write the first two terms. We add 5 on 2, so b on 2, and we square it. And then because we added something, we've got to take it away. And then don't forget the plus 2 on the end, and we'll let that equal 0. All right, so we're factorizing the first three terms. Okay, so it's a perfect square, always will be a perfect square, and it'll be x plus whatever is in the brackets here. So x plus 5 on 2. Again, just leave it as a fraction. Then we've got minus 5 on 2 squared, so I'm going to square that. So 5 squared is 25, and 2 squared is 4. And now because I'm going to have to deal with fractions, I'm going to change that to be 8 over 4, okay, just so we can add these fractions together. All right, so I've got x plus 5 on 2. Then negative 25 plus 8 gives me negative 17 over 4 is equal to 0. Now, I would leave it just as fractions like that. I probably should have done a nicer one to show you how this relates with the quadratic. But basically, this number here tells you whether it's been shifted up or down. Oops, got the square here. And this number here tells you whether it's gone left or right. So remember when I showed you with the quadratics before, I moved them up or down. I didn't move them left or right, but they can move left or right. And when it's in this form, which we call turning point form, it tells you what your turning point is and whether it's shifted up or down and whether it's moved left or right. Okay. When we get to parabolas, that'll probably make more sense. But if you're wondering why do this when we can use a quadratic formula, that is why. All right, so we still need to complete the square. Oh, we've completed the square, sorry. We need to factorize using the difference of perfect squares. So it's fine to get it in this form, but we need to keep going. Remember, you can only factorize it if there was a negative here. Okay, so if that was a positive, your parabola has been shifted up and it doesn't cross your x-axis. Okay, so that's the whole purpose of that. So this graph is a parabola. It's been shifted down by 17 over 4. So therefore we have x-intercepts. But if it was a plus, it would be a parabola that has moved up and it would no longer cross the x-axis. Okay, so remember your difference of perfect squares, a squared minus b squared equals a plus b, a minus b. So that's all we're doing here. So this is going to be your a squared, this is your b squared. So a is equal to x plus 5 on 2, and b is equal to the square root of 17 over the square root of 4, which is 2. All right, so difference of perfect squares. So a plus b, x plus 5 on 2. And then we've got plus root 17 on 2. And then we've got a minus b. So just finishing it off there. I would add these together, see how they've got the same denominator. So we're going to have x plus 5 plus root 17 on 2. And then x plus 5 minus root 17 on 2 is equal to 0. And then we can still solve. Okay, so we just separate the brackets. Just because we've got a third in there, it doesn't make any difference. The working out is still the same. Actually, it would be a good time to show you, oops, I've gone ahead and done the solution. Sorry, I'm skipping a step. I could show you at this point the quadratic formula. I might leave it because we're not going to be doing it for a while. But some of you may have already seen the quadratic formula. Okay, so that means x is equal to 5, negative 5 plus root 17 on 2. Sorry, I was going to write 0 there, but I shouldn't have. And then this is x equals negative 5 minus root 17 on 2. And then when that negative goes in, okay, it's going to be, and you can put your negative like that. So the negative is multiplying both the negative 5 and the root 17. Okay, so we've got our two solutions. The only difference is that sign in the middle. Now that is quite a tricky one. When you do the quadratic formula, you'll get the same solution, okay, with the surd and everything like that, but make sure you can do it by hand as well. All right, I put in example 6 just because I thought if you thought it was more complicated than what it is, but it isn't, as the question says, you just need to take out the coefficient. So here we're going to take out the number 2. So we're left with x squared minus 2x plus 2 equals 0. This 2 doesn't affect your solutions. And if you wanted to, you can say, well, if I divided both sides by 2, that disappears anyway. So that coefficient makes no difference, which is nice. Okay, so then we're just dealing with x squared minus 2x plus 2. And let's just, because we can do another example of completing the square, we'll complete the square. So we're going to have x squared minus 2x. The coefficient of x is negative 2, so we're going to add negative 2 on 2 squared, and then we're going to take it away, negative 2 on 2 squared plus 2 is equal to 0. So when we factorize the first 3 terms, we're going to have x and whatever is in this bracket. So negative 2 on 2 is negative 1 squared. Negative 2 on 2, negative 1 squared is 1. So minus 1 plus 2 equals 0. And then we've got x minus 1 squared. Minus 1 plus 2 gives you plus 1. Now here is an example of one that you can't factorize any further, and I'm just going to make sure I haven't made a mistake anywhere along the line. So let's actually graph it. So we're going to have 2x squared minus 4x plus 4. All right, so I've just put it in here. You can see, remember the f is just the same as your y, so y equals 2x squared minus 4x plus 4. Oops. Okay, and there's the graph there. Now remember when I was saying before, you need to know whether you can actually factorize it. And this number here, when we complete the square, if it's a positive, we can't factorize it. And there's an example of why we can't, because here's the graph of 2x squared minus 4x plus 4. It is not crossing the x-axis, therefore we can't find any solutions, no real solutions. And you can also do solve on your calculator. So if you ever want to check your answer, you can use solve. So I'm just going to add a page. Whoops. Just wanted to do that, go away. Sorry, control. Oh, my calculator's not cooperating. Let's just go to on. Okay, so solve, similar to when we were doing linear equations. So 2x squared minus 4x plus 4. This time we can let it equal 0 because we're solving it. We're not just graphing it. And it comes up false. And don't think that you've made a mistake, but as I explained before, it's a parabola that doesn't cross the x-axis. So that's why you would see false there. All right, let's move on to question 7. So again, it says solve them if possible. Okay, so again, we're completing the square. The only difference here is we have our constant on the right-hand side, so we just need to bring that over. So we've got x squared plus 3x, and that 5 I'm going to bring over to the left side, and then that equals 0. Now we can solve using completing the square. So first two terms stay the same. And then we add the coefficient of x over 2 minus 3 on 2 squared, and then minus the 5, and let that equal to 0. I think we're going to be able to do this one. So x plus 3 on 2 squared. Just take your time when you're dealing with fractions. So 3 squared is 9. 2 squared is 4. Minus 5. Now you can leave it as minus 5, but we're going to eventually have to deal with fractions here. So let's rewrite that as 20 over 4, just so we've got the same denominator. I'm just making sure I haven't made a mistake anywhere. Okay, so we've got x plus 3 on 2 squared. Minus 9 minus 20, so minus 29 on 4 is equal to 0. Now remember, this negative means that we can do the difference of perfect squares. So my a in this case is x plus 3 on 2. And the b is the square root of 29 over the square root of 4, which is also 2. Okay, so then we've got a plus b, so x plus 3 on 2 plus root 29 on 2, and then x plus 3 on 2 minus root 29 on 2. So I'm just doing the difference of perfect squares here. You can tidy this up a little bit. So x plus, because you got the same denominator, so we'll put it all over 2. I don't change that x. The x can just stay like that. You'll probably be complicating it if you did put it over 2. Okay, you don't need to. And I'm just making sure I'm not making any errors here. So then we separate our bracket. So we've got x plus 3 plus root 29 on 2. And sorry, my writing's getting a little bit messy as we go along, but hopefully you can follow. All right, so that means x is equal to negative, and make sure you put it in brackets because that negative applies to all terms, not just that 3. Okay, and then our final answer, we're going to have x equals, when I put that negative through, then we've got negative 3 minus root 29 over 2, and x equals negative 3 plus root 29 over 2. Now, if you did it in your calculator, it might switch things around. Okay, so the calculator tends to put the positive number first. So just make sure when you do something on your calculator to check the answer that you do take that into consideration. All right, so I might stop there, girls. It's a long video, but just make sure that when you're thinking about these answers, how they relate to your parabola. But we're not actually learning about parabolas just yet, but it helps give a bit of context to the solutions. All right, bye.